What is an equation? Well, an equation is when something equals something else. When something equals something else. For example, 2 plus 3 equals 5. Something equals something else. Something equals something else. So let's use a picture to explain this concept a little further. Let's say we have a person. Happy person. And we're going to make an equation out of this person. All right, here they are. So we have a person equals person. Whatever's on the left side of the equation is on the right. Something equals something else. So what if I do this? What if I give this guy an umbrella? Well, the left side of that equation looks a little different than the right. The guy on the right does not have an umbrella. So to make both sides the same, to make something equal something else, the guy on the right needs an umbrella. Well, what if the guy on the left wants to wear a hat? The left side looks different than the right now. That means to make both sides equal, this guy needs a hat. For an equation to work, you need the left side to be equal to the right. In other words, the same thing is on both sides. So we had a person, and we gave him an umbrella. And so we had to give the person on the right an umbrella, because we needed to make sure the same thing was on both sides. When we added this hat right here, we needed to add a hat over here. For an equation, if you do something to one side, you must do the same thing on the other side. We do this to maintain the equality. Maintain the equality. If we gave the guy here an umbrella, but we did not give this guy an umbrella, whatever's on the left is not equal to what's on the right. They're different. We're not maintaining the equality. We could say that these are not equal. So, to maintain the equality, we have to give the guy on the right an umbrella. Left side equals right. Same things on both sides. Okay? That is what an equation is, and it's important to understand that, because the problems in your book are not going to have happy men like this. They're going to have equations that look a little like this. Solve for x. 3x minus 7 equals 2. We have something equal to something else. And it says solve for x. Well, that just means get x by itself. What is x? X is a variable. And a variable is just a number in disguise. Okay, let's just take a look at this. We're not going to worry about the whole problem. We're just going to take a look at this 3x minus 7. So our goal is to get x by itself. So we want to have something where once we're working down the problem, we would get x equals something. X is the variable, the number in disguise, so we want to figure out what is underneath the mask. What number is x? So that means we have to take this 3x minus 7 and do some operations. Remember operations, addition, subtraction, multiplication, division. We have to do some operations so we get x by itself. You want to work on this step by step. What can we do to get closer to just having x by itself? Well, we can add 7 to this because we have 3x minus 7, and if we add 7, then all we're left is 3x, because that minus 7 plus 7 just becomes 0. Okay, now we have 3x, or 3 times x. What can we do to that to get to our final answer here of x? We can divide by 3. And if we divide by 3, then we're left with x. So that's the kind of process you want to think about when you're actually solving an equation. 3x minus 7 equals 2. Something equals something else. Same thing on both sides. Remember, what you do to one side, you have to do to the other. Right? We gave the guy on the left an umbrella. That meant we had to give the guy on the right an umbrella. Same kind of idea. Remember, our end goal as we work down the page is we want to get to x equals something, right? So as we did on the left side, something we can do is to get closer to that x is we could add 7 to that 3x minus 7. Well, with an equation, if you do something to the left side, you also need to do it to the right side. So what do you have after that? So you added 7 to both sides, so you get just that 3x, and that minus 7 plus 7, that just becomes 0. And on the right, you have 2 plus 7, becomes 9. Essentially, you could think that we just started off with a person, and then we added an umbrella. That plus 7 is that umbrella. We have to do the same thing to both sides. Okay, well, what do we do now? Well, we have that 3 times x, and you can think of this sort of as undoing processes. If we look back up here, you had 3x minus 7, and how do you undo a minus? You add. So we had minus 7, and you undid that by having that plus 7. In a similar way, you can undo that 3 times x by dividing by 3. And so you have to do that on both sides. And what you're left with is, let's bring this x up here. 3 divided by 3 here is just x. And then on the right side, you have 9 divided by 3 is just 3. And that is your answer. We figured out that the value underneath the mask is 3. So let's take a step back and ask ourselves, what just happened? We were given an equation, and what did we do after that? We did the same math on both sides until x was by itself. So now let's rewrite that equation. So now we have 3x minus 7 equals 2, our original equation, and we know that x equals 3. That means this guy right here is 3. So let's substitute that in. We don't need to have that number in disguise anymore. We know what it is. It's 3. So let's substitute that value in. So we'll have 3 times 3 minus 7 equals 2. Okay, on the left side, 3 times 3 is 9, minus 7 equals 2. And then we have 9 minus 7 is 2 equals 2. 2 equals 2. We have this situation. We have whatever's on the left equals what's on the right. And the way that we solve this equation by doing the same math over here in orange, that maintained that equality, because we started off with something up here equaling something else, and because we did the same thing on both sides, we maintained that equality, and we ended up, when we plug in that 3, we end up with a true equation. So we can say that x equals 3 makes the equation true, meaning that value, when we plug it into the equation, maintains the equality. So what happens if you got something else instead of 2 equals 2? What if you got 2 equals 5? Well, that's not right. So, need a little more space. If you plug in your solution and you get a false statement, like 2 equals 5, then your solution is not correct. And you need to check your work to find the error. If you ended up with 2 equals 5, that is clearly a false statement. 2 does not equal 5. At every step in the process, your equation has to be true. Over here, we added that 7 to both sides to make sure the left and the right were the same. And then we did the same thing over here. We divided by 3 to make sure the left and the right are the same. If we made some error here, then we might end up with a different answer. We might end up with, let's say, x equals 5, or anything else. And when we go back and we plug that number into our equation, we'll see that we'll get a false answer. In this case, we'll get 8 equals 2. 8 does not equal 2. I just did a little quick math. I plugged in that 5 in for x. It would be 15 minus 7. So if you got something like 8 equals 2, math did not just break, you did something wrong. So you have to go back and find that error. So always try to remember this little diagram. Someone on the left, someone on the right. You have to make sure they're the same. So let's do another example. So let's consider 2x. So what is 2x? That's 2 times x, right? Well, 2 times x we can just think of as x plus x. So x plus x is 2x. And you can think of it as this is 2 x's. Well, then what is 5x? 5x is x plus x plus x. And this is done 5 times. And you can think of this as 5 x's. Okay, so when you see 5x, you think you add x 5 times, or it's just 5x's? Well then, question is, what is 5x minus 2x? Well, you have 5 x's, and you subtract 2 x's, and then you're left with 3 x's. So that's a way to think about it. And it doesn't actually have to be x. Remember, a variable, just a number in disguise. We usually use like an x or a y, but we don't have to. What if I just said 2? Let's just do a little drawing. We're gonna just draw a present. Why not? Okay, that is something of a present. All right. Instead of x, we have 2 times present. It's a number in disguise. We just gave it a different disguise. It doesn't have to be x. So let's say, so what is 2 present? 2 times present. That is present plus present. So you can think of this just as, instead of the x, I just used anything else. You could use anything. It's just a number in disguise. So this is just the same as 2x equals x plus x. And in the same way, we could say that 5 times present times that variable is equal to, I just took x, we just said it's a number in disguise, and I gave it a different disguise. So we could also rewrite this question as, what is 5 times present minus 2 times present? Well, you have 5 presents, and you subtract 2 of them. What do you have left? You have 3. 3 presents left. Now, what if we found out what's in that box? What's under that disguise? What if we said it's 7? Well, that means that 3 times present equals 3 times 7. And that is equal to 21. We'll see in the next example why this is important. Just to think of a variable as a thing. We have 2 of something, we have 5 of something, and to not be afraid of variables. Very important. So let's do one more example. Solve for x. And we have 8x minus 2 equals 3/4 times the quantity 20 plus 4x. Something equal to something else. That is what we have here. Well, there's a lot of operations. We have some multiplication, we got some subtraction, some parentheses, addition. Well, we got a lot of operations. Maybe we can try PEMDAS. If you saw our order of operations video, please excuse my dear Aunt Sally. Maybe that'll help us. We've got some parentheses. Multiplication, we saw that. Addition and subtraction. Okay, so let's try using PEMDAS. And that says to focus on the parentheses first. So right here, 20 plus 4x. There's not really anything we can do in there. Our goal is to solve for x. We don't know what x is, so we can't really make that any simpler inside. We can't simplify it. We're actually done with that parentheses step. Next is multiplication. Looks like we're multiplying a 3/4 here. If you see something like this, there's an implied multiplication point right there. So multiplication is our next step. So I'm gonna clean up this area. So how do you multiply a number by something that's in parentheses? That is called the distributive property. And that says you multiply that outside number by each piece on the inside. So what we do, let's rewrite our equation. So we're not even focusing on the left side, so let's just leave the left side the same. On the right side, we'll have 3/4 times that 20 that's on the inside of the parentheses, and then we'll leave that plus, and then we're going to multiply 3/4 times that 4x that's in parentheses. So that's the distributive property. Looks like we can simplify this a little. We have that 3/4 times 20, so we can make that a little simpler. So let's rewrite our equation. Very helpful to take space on your paper, write neatly, and it will help you to avoid errors. So we have 3/4 times 20. So how do we solve that? So we can write it as 3/4 times 20 over 1. We know 20 can be written as 4 times 5. And we can cancel out the 4's. And so let me write this first. Write this as 4x over 1. As you can see, we can cancel a 4. So let's rewrite this and make this a little less messy. 8x minus 2. We're not doing anything to the left side right now. We're just trying to make things a little simpler. We cancel out those 4's here. So it's going to be 3 times 5 over 1. So that's just 15. Plus, we'll have 3 times x over 1. It's just 3x. And now we have an easier problem. So what do we do? Well, remember, our goal is to solve for x. We want to get x by itself, so we want to get something down the road that looks like x equals something. We want to figure out what x is. So let's figure out how to do that. So remember our present problem? The reason I did this is I want you to think of these variables as things. You have two things, two presents. You have 5 presents here, and you took 5 and you subtracted 2. Similar thing here. We want to get x on the left side. So what we're going to do is we're going to subtract this 3x. Remember, we had to have the same thing on both sides. So you subtract 3x from both sides. And what that does is leaves us with 5x minus 2 equals 15. We just subtracted 3x's from both sides. So we have 8x's minus 3x's here, and that led to just 5x's. What can we do now? We have just the x's on the left side, so we want to get closer to having it by itself. So let's take a look at that minus 2 there. What's a way to undo that? Well, we could add 2. And then we have to do that to both sides. And that leaves us with 5x and minus 2 plus 2. That goes to 0 and equals 17. So when I say undo, it's kind of like make it disappear. Over here, we did minus 2 and then we added that 2 just so it would become 0. So it would disappear, just so we have x closer to being by itself. Same thing up here. We had 3x and we subtracted 3x just to get that to disappear and bring the x's all the way to the left side. So now that I've said that, what do we do here? Well, we have 5 times x. A way to get that 5 to disappear is to undo it by dividing by 5, but we have to do that to both sides. This is maintaining the equality, as we talked about. And 5 divided by 5, that cancels. And our final answer is x equals 17 over 5. And you could write it as 3 2/5. That is our answer. So that is what an equation is. We have something equal to something else, and we have to do operations such that we do the same thing to both sides. And we do operations that undo what's going on so we can get x by itself. So I encourage you to rewatch this video, take some time to definitely go over the present example, and think of variables as just things. They're things in disguise. Remember? They're numbers in disguise. It's two x's, two presents, two balloons, two smiley faces, and you're just moving them around. Up here we had 5x minus 2x. It's just 5 things minus 2 things. You have 5 apples, you subtract 2 apples, and you're left with 3 apples. So take some time, ask questions, write neatly, use space, and you'll get it soon enough.